This is lesson 38 on decoders. This is an example of a 2 to 4 decoder. There are 2 inputs, A and B, and 4 outputs, Y0 to Y3. Only one of the Y's is 1, depending upon what the input is. If the input is, say, 1, 0, 1, then Y1 is 1. If it's 1, 1, say 3, then Y3 is 1. Sometimes the outputs are active low, as shown here, in which all the outputs are 1 except the one which selects the input. So the output decodes the input. You can tell what the input is by just looking at which of the outputs is 1. Here's an example of a 3 to 8 decoder. There are 3 inputs, 0 to 7, and 8 outputs, Y0 to Y7. One of the outputs is 1, depending upon what the input is. So in general, a decoder will have n inputs and 2 to the n outputs, and often there's an enable signal. If this enable signal, for example, is 1, then it behaves as a binary decoder. Otherwise, all of the inputs are either all high or all low, depending upon whether the outputs are active high or active low. Here's an example of a TTL decoder. This is one of the old 74139s. It's a dual 2 to 4 decoder, and it has an enable signal G. In this case, the outputs are active low, depending upon the inputs B and A, but G has to also be low to enable it. If G is 1, then it's disabled, all the outputs are 1. Incidentally, this decoder can also be used as a demultiplexer. You remember multiplexers took, say, 4 inputs and fed them to 1 output depending upon the control signal. Here we can think of the control signals as being B or A. Here the input is G, and now there are 4 outputs. So you see, depending upon what B and A are, then this value of G will be steered to the corresponding output. If G is 1, then it's disabled and that output will be 1, so it looks as if it just goes through. So this is a case of a demultiplexer, just the opposite of a multiplexer. Here is another TTL 3 to 8 decoder, the 74138. Here there are 2 enable signals. G1 has to be 1, G2 has to be 0 to enable it, and then there are 3 inputs, C, B, and A, and again this is a case of an active low output. This shows how you can make a 3 to 8 decoder from 2 to 4 decoders. With an enable signal, notice that A2 is connected to the enable of the second one, and then through an inverter to the enable here. So if A2 is 0, then this enable is 1 and this one 0. So these will all, say, be low, for example. And then as A0 and A1 goes to 0, 1, 2, 3, the output will go to D0, 1, 2, 3. Then as soon as A2 becomes 1, so you're at, say, 4, 5, 6, and 7, when this is 1, this is 0, so it disables the first decoder. These are all zeros. This one's enabled, and now when it goes 4, 5, 6, and 7, the outputs will go 4, 5, 6, and 7. This shows how to make a 4-input tree decoder. Here there are 5 2 to 4 decoders, and it produces a 4 to 16 decoder. This first one, this is enabled, so for example, suppose the input is a 6, 0, 1, 1, 0. Then in this decoder you really have a 0, 1, which is a 1, so the 1 output comes out, and these outputs all go to the enable of each of these 4. So only this one is enabled, the others are disabled, so their outputs are all 0. The X1 and X0 inputs go to all of the 4 inputs on level 2, but since only this one is disabled, the 1, 0 here, which is a 2, is a 1, 0, so the 2 output is 1, and this is Z6. So the 0, 1, 1, 0 gets decoded in this 4 to 16 decoder. This is what's called a 4-input coincidence decoder. There are two 4 to 16 decoders. This one provides all of the column. This 4 to 16 decoder provides all of the rows. And at each intersection there's an AND gate. So for example, this shows an example where the 8-bit input is 0010, 0100, which is 36. The output of this one, since it's 0010, it's really a 2, so this 2 out of these 16 outputs goes along, which just enables this row. And then the input to this one is 0100, which is a 4, so only the 4 output line is high. And so when this column is high and this row is high, only this AND gate is enabled, and so the Z36 output gets connected to 1. These coincidence decoders are often used to decode RAMs, for example, where this could be an input address to a RAM, and you could select a particular bit location to enable.